We're going to start a brand new topic, which is for separate physics only. It's quite an interesting topic. A lot of students enjoy learning about it. It's space physics. The initial lesson is solar system, our solar system, what it contains, what it's about. Bit of an introduction to the scale of the universe and how stars are formed. Obviously, our sun is a star which is at the centre of our solar system, which is fairly fundamental to us. So let's go. So what do we mean by solar system? Well, the word solar means it relates to the sun. So anything relating to the sun is known as solar. So solar energy, solar flares, solar wind. They're things that you might come across when looking at things in space. And so a solar system is a system of things which go around a star, or in our case, the sun. So the word solar means our sun. So strictly speaking, other solar systems exist, or other star systems exist. They shouldn't be called solar systems, but often they are. And they should be called star systems, because those stars are not our sun. Anyway, let's move on. Right, so what's in our solar system? Obviously the sun, otherwise it wouldn't be called a solar system. And orbiting the sun are a number of other things. So there are 8 planets. There used to be 9, but Pluto was downgraded to a dwarf planet. It's too small to be classed as a planet now. But I've left it there, you'll see why in a minute. There are moons. They orbit planets. I put the phrase there, natural satellites, because other things orbit at least our planet, which are not natural, i.e. man-made satellites, which we use for communication purposes. So to distinguish between those, we use the phrase natural satellites, which are called moons. Obviously, man-made satellites are not called moons. Then we have comets, which are lumps of mostly ice with bits of dust and rock embedded in them, and they have very elliptical orbits which disappear off into space, potentially for hundreds of years, and then they come back into our view, whiz past the sun, and then fly back out into space for the next few hundred years. When we look at orbits and how gravity behaves and determines orbits, then you'll see some comet-like orbits in the animations that I'll show you. And then we have asteroids, which are relatively circular orbits going around the sun, with the sun at the centre, but they're too small to be classed as planets. Some of them are very big, almost planet-sized, but some of them are very, very small, and there's bits of dust and grains of stuff and all sorts of all very high variety of different sizes of bits of stuff floating around. Okay, so why did I include Pluto? Well, if I didn't, this sentence wouldn't make sense. So this is how I remember the order of the planets. My very easy method just speeds up naming planets. You'll notice the the letter of each of those words is the beginning of each of the planets. The only other thing then to remember is you've got 2 M's, so which one's Mars, which one's Mercury? Well, Mercury begins with M and ends in Y, so does Mi, which makes that nice and easy to remember. Okay, so let's have a look at the scale of our universe, at least in terms of the diameters of the things. So I've drawn this diagram to scale according to the diameter of the object. So you can see the sun is huge compared to the other planets in our solar system. It's actually a fairly average star. It's not a particularly big star. In fact, it's quite a small star. You'll see more about that again later on in the topic. But for now, I think it's quite big. I've included, that's my mouse pointer, there it is. I've included the moon, which is just above my mouse cursor now. You might not be able to see it if you're on a small screen. In fact, if you're on a really small screen, you might not even be able to see Mercury, which is there. So we've got Mercury, Mars, etc., all the way out there. There's more information about these planets in a video that I've put a link to in the workbook document that you'll get as well. Okay, continuing on the scale of things, let's look outside of our galaxy. This is an artist's impression. Obviously, we can't take a photograph of the thing that we're inside. We have to leave that thing to take a photograph of it, and you'll see in a minute it's too big to leave. We wouldn't be able to get outside of it anytime soon. Right, so this is an artist's impression of the galaxy in which our sun is in. It's a little orange circle or yellow circle here, indicating roughly where within that galaxy our sun is, or the sun is. Each of these tiny dots represents a star, and when you've got massive clusters of brightness, that's loads and loads of stars. There are millions upon millions upon millions, if not billions upon billions of stars in our galaxy. Our galaxy, incidentally, is called the Milky Way. Not sure why chocolate bars like to be called after space things, but they do. So we've got Milky Way, which is the galaxy that we exist in. It's big. But again, in the grand scheme of things, it's not that big. It's fairly typical. But relative to us, it's huge. So it's 105 light years across, from one side to the other, from here to here, 105 light years. What does that mean? Well, a light year is how far light travels in 1 year. And it travels at approximately 300 million meters per second. So if you take 300 million, times it by 60 seconds per minute, 60 minutes per year, 60 minutes per hour, 24 hours per day, 365 and a quarter days per year, we end up with this number here in meters. So if you divide that by 1,000, take off 3 from there, we end up with 9.5 times 10 to the power 12 kilometres, or in other words, 9.5 million kilometres, or thereabouts. It's big. Okay, final bit of the lesson then, a little bit of information about how stars form, just to conclude. We'll cover this in loads more detail, massive amount more detail in a future session. But for now, we need a little bit about how stars form. So space is basically empty, but there is pockets or bits of dust and gas and things in places. It's fairly spread out, and the large clouds of dust and gas are known as nebula. So these nebula consist of very, very diffuse bits of stuff. The other thing you need to be aware of is that any object with mass will attract by gravity any other object with mass. So you place 2 marbles on your desk, there's a force of gravity pulling them together. Clearly they don't move together because there's friction, which is much bigger than the very weak force of gravity. If you do A-level physics, then you'll be able to calculate the force of gravity between 2 marbles, and you'll realise it's very, very, very small. But if that's the only force acting on them, even if it's very, very small, then they will start accelerating towards each other. Initially very slowly, but they'll get faster and faster and faster. So over millions of years, these nebula start to contract because gravity pulls them towards their centre of mass, like this. Okay, so these blue dots representing particles of gas in a nebula cloud. They collapse in on each other. As you saw, as they got closer together, they lose their gravitational potential energy, but they increase their kinetic energy. Gas particles, kinetic energy represents the temperature. As you squeeze them into tighter space, that increases pressure. So we end up with bits of gas, very high temperature, very high pressure, and they start to glow. And when they glow, it's called a protostar. It's giving off light, but it's not yet properly a star. It's only a star when enough energy is present, high enough temperatures and high enough pressure is present, so that fusion can take place. And we looked at fusion in a previous lesson, so you should be aware of the process there. But we'll look at it again in a future lesson when we look at this in more detail. So, this is not in the right order, by the way, but key process then. Nebula is a dust cloud, collapses under gravity, temperature increases, you get a protostar, continues to collapse, get hotter and hotter and higher pressure, fusion starts taking place. It's then a star, and it's known as a star on the main sequence. Okay, I wouldn't worry too much about that yet, but know that most stars exist in their main sequence phase for most of their life. That's it. Over to you. You can have a go at the workbook, have a watch of the videos, etc. And I'll speak to you next week.